Hey gang, we're back with part two of the review. We've talked pumpkins here. Now we're going to talk about the diver. So let's come over to my paper and we will look at what's happening. Okay, so I already did the drawing. All right, well, I did the drawing once. I didn't like it, so I threw it away and I did another one. Okay, so we're going to have this diver that's going to make this arc. Okay, and there's all sorts of things we're going to have to find out about this scenario, but the very first question starts off easy, or starts off at least at the beginning, which is a nice place to start, and that was question A is just, what is my velocity in the y initially? Okay, so what we can do is we can take this triangle and just break it apart and look at what was that part over here. Okay, so when we do that, that is opposite the angle. So SOHCAHTOA tells us that we're going to have to do our hypotenuse times the sine of theta. Okay, so that's what we're going to do over here. So V1 of y is going to equal, whoops, I didn't put what my V1 was. That was 8 meters per second. Okay, times the sine of 60 degrees. Okay, so once again, make sure you're in degrees. You should probably do that at the very beginning of your test. Everything we do in kinematics and mechanics will be in degrees. Okay, we will eventually get to radians and some of the other stuff. But right now, degrees does what we need to and works well with the engineering that this could be applied to. Okay, so we're going to do 8 times the sine of 60, which will be 6.93. Okay. Okay, I know calculators go out to a lot of different numbers, but our measurements are really only 1 or 2 decimals, so I don't want to go overboard and express confidence in things I'm not confident in. Okay, all right, so that means we can go on to part B. How much time was she in the air? Okay, all right, so let's take a look at that. All right, so now we need to get a lot more formal here. This one was very easy, it was just a triangle, but now we need to start doing our list of knowns, okay? So let's start figuring out what do we know here, okay? So we knew Vy, we know dy, and we know acceleration in the y is 9.8. Okay, we'll eventually have to do the x's, but right now it doesn't look like the x is really going to affect our question here. Okay, so if we're looking for time, we know acceleration, we know velocity, we know distance. Okay, so that means we can go to our old standby here. Oops. All right, so we get our whole equation in there. Sorry about cramming that in. Now we can start filling in what do we know and what do we don't know. Okay, so we know when she hits the ground, dy final is going to equal 0 meters. So I'll have 0 meters equals, all right, and then 6.93 times, this is what we're looking for, okay, plus, running out of paper here, we're going to just pretend this paper is a little bit longer, okay, plus 1/2 9.8 t squared. Okay, not beautiful, but it kind of works. Okay, I have not put any signs in here yet because I want to talk about what's up and what's down. So she started up above the ground, she jumped up, but she was pulled down. Okay, so that's how we're going to have to fill this out here. All right, so now we can start plugging this in. 0 equals 2 plus 6.93 t plus 1/2 of 9.8 is negative 4.9. Okay. All right, so in an ideal world, you would just look at that and know the factors of 4.9s and 6.93s, but that is not where we are today. We're going to have to do something like, okay, it already equals 0, okay, which means this, our C is 2, our B was 6.93, and our A was negative 4.9. Okay. All right, so we're going to come in and do the quadratic formula here of negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so we're going to have negative 6.93 plus or minus the square root of 6.93 squared minus, this is where I keep using my paper here, 4 times negative 4.9 times 2, all that over 2 times negative 4.9. Okay, so it's possible if you have a graphing calculator or programmable calculator, you might just be able to plot those in there. That is fine with me. Okay, you should get 2 numbers out of this. Okay, you will either get 1.66 or 0.24, but that is a negative. Okay, so mathematically, they're like, oh, look, we could come back here, and if you go backwards in time, you would also hit the ground. Well, we do not go backwards in time in physics, and there's a lot of discussion on why that does not happen. But we just know, as engineers and scientists, we do not go backwards in time. Okay, so this is going to be our time in seconds right here. Okay. All right, little reminder, give yourself space for all this. I should have put my drawing on a separate page, but I try to keep going here. All right, so let's go on to part C here. What is our velocity in the x direction? Okay, that's starting to get a little bit easier. All right, I'm just gonna kind of put this aside. I like my drawing. All right, now we're looking at what is her velocity in the x. Okay, we said opposite was sine, so v of x is going to equal v1 cosine theta. Okay, so let's work with some of that. Okay. All right, so we're going to have v of x equals v1 cosine theta, where v1 was 8 meters per second times the cosine of 30 degrees. Okay, so once again, either you know your unit square or unit circle. Ooh. All right, I don't know why I wrote this. I said it correctly. This was a 60-degree angle. Let's make sure I get that right. Okay, I put in my calculator correct. All right, and this is going to be exactly 4 meters per second. Okay, all right, so that takes us through part C. All right, that was part C. And then part D asked, how far did she travel in the air? So that's really, we want to know dx. Okay, so the whole point here is we're trying to find the this distance. Okay. All right. So, and if we remember back to our pumpkins, how do we find dx? The velocity in the x times time. Well, lucky for us, we know velocity in the x, and we know time. Okay, so that's all we're going to have to do. All right, now quick. 4 times, what's that, 5/3? Okay, 20/3. Everyone knows 20/3 in their head, of course. Okay, so that should be about 4.6. Excuse me, 6.6. That's what I get for being dyslexic. All right. And that is our distance, meters per second times seconds. There we go. All right, so I'll try to, in terms of testing, this is how I would do it. These would be distinct questions so that I can grade you on each of those skills and each of those standards independent of each other. Okay, so that should take us through the end of the review. Okay, if I come back over to the equations, okay, that's always a nice place to end. Notice we spent a lot of time with this first equation, a lot of time with the last equation. There might be 1 or 2 situations where we have to use something else in terms of the v² type number or the acceleration times time. So there's a chance for us to avoid using time, and there's a chance for us to avoid calculating distance. But other than that, we've worked our way through our samples, so hopefully we get some good questions tomorrow in the review going into the test that you'll take this weekend.